In this lesson, we're going to look at geometric sequences. We're going to define them and look at some notation. We're going to identify geometric sequences. We're going to look at recursive formulas, and then we're going to compare arithmetic and geometric sequences together. A sequence where the ratio between consecutive terms is constant is a geometric sequence. This constant ratio between terms is called the common ratio. Now that may seem like a foreign language to you. Let's look at an example so we can understand a little better. So here we have a sequence of numbers, 2, 8, 32, 128. This is a geometric sequence, and the reason why it's a geometric sequence is if you divide 8 by 2, you get 4. And if you divide 32 by 8, you get 4. And if you take 128 divided by 32, you get 4. That number is called the common ratio. If I go backwards, 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128, 128 times 4, have to grab my calculator because I can't do that one in my head, is 512. And you remember this is the first term, second term, third term, fourth term, and this is the fifth term. And that's what it's asking for here is the fifth term of this sequence, which is 512. That's what this little subscript means. And the common ratio is 4. Let's look at a second example. Determine the common ratio and the next term. So I still want to go 64 divided by 128. But when I do that in my calculator, I get 0.5. And that's because this is a decreasing sequence. So you're going to multiply 128 times a half to get 64. And then 32 divided by 64 is a half. So 64 times a half is 32. The common ratio is 1/2. So you divide this direction to figure out what your common ratio is. And then to find the fifth term of the sequence, you multiply. 128 times a half is 64, 64 times a half is 32, 32 times a half is 16, and 16 times a half is 8. So the fifth term of the sequence is 8. Just like arithmetic sequences, one of the ways to represent a geometric sequence is by using a recursive formula. A recursive formula relies on the previous term to find the nth term. Honestly, they're not super useful because you have to know every previous term, but it's good to know the notation. So just like with arithmetic sequences, this means any term in the sequence. This means the previous term. So whatever the term was that came before, and then R is your common ratio. I almost said difference. Did you hear that? I'm stuck on arithmetic. So you're basically going to do what we did before, and you're going to multiply the previous term times the common ratio. So times a half or times 2, whatever the number is that's in the pattern. We can also write it with function notation. This just means, again, previous term. And of course, the R is still our common ratio. Moving right along. Let's take a look and make sure that you understand how to read a recursive formula. So we're going to find the first 5 terms of the sequence. So again, just like I did with the arithmetic, it really helps me to list out 1, 2, 3, 4, 5 so I can make sure that I've got the numbers that it asks for. It asks for the first one, which is always given to you. Yay, we're doing good so far. For the second one, we're going to take the previous term and multiply times 3. So that's our common ratio. So we're going to take our previous term, which is 4, times 3 is 12. And then we're going to take 12 times 3 is 36, and 36 times 3 is 108, and then 108 times 3 is 324. It's not hard. It's just a matter of understanding what this is saying. This is the first term, and this means the previous term. Let's take another look at another example, this time in function notation. So same concept as the subscript notation. This means the previous term, and we're going to take it times 2. And the first term is 5. So it says to list the first 4 terms. So 1, 2, 3, 4. Okay, so the first term is 5. The second term, multiply it times 2, would be 10. Times 2 would be 20. Times 2 would be 40. Let's go ahead and do 5. So times 2 would be 80. It doesn't ask for that, but when we do the graph here, so 1, 5, 2, 10, 3, 20, it looks kind of linear, but then 4, 40, 5, 80, you can see it's not linear at all. It's non-linear. The domain, excuse me, is all the x values. And we don't want to connect these dots because these represent the terms. And it doesn't make any sense to have 1.5 terms or 2.5 terms. So this is a discrete function, so we're not going to connect it. So the domain is going to be positive integers, also known as whole numbers. All whole numbers. That's a U. All whole numbers. No decimals, so we can't say all real numbers on this one. To wrap up this lesson, we are going to compare arithmetic and geometric. So remember, arithmetic has a common difference and geometric has a common ratio. So when we look at the difference here, it's -3. So that's arithmetic because it's always the same and it has a common difference of -3. Then for here, the difference is 8 and then 6 and then 1 and then some kind of fractions. It's definitely not arithmetic. Let's do 8 divided by 16 is 1/2. 2 divided by 8 is 1/4. Uh-oh, this is neither. Neither one. So it doesn't have a common difference or ratio. Here, it's 12 divided by 2 is -6. -72, handy dandy calculator, divided by 12 is also -6. 432 divided by -72 is also -6. So I automatically, you notice how I automatically jumped to geometric? Because I can see that that gap is getting bigger. So it's definitely not going to be arithmetic. It might be geometric, and so then I divide them to see if I get the same number every time, and I did. So it has a common ratio of -6. This one looks the same. It's not changing very quickly, so I'm guessing it's arithmetic. So let me look at the difference here. That's a +2, +2, +2, +2. That's an arithmetic sequence with a common difference of 2. And I can see that this one's happening pretty rapidly, so I'm going to guess that it's geometric, and I'm going to take 72 divided by 144, and I get 1/2. 36 divided by 72, I get 1/2. 18 divided by 36, I get 1/2. I'm always getting 1/2. So it's geometric, and my common ratio is 1/2. So now hopefully you have a little bit better understanding of arithmetic and geometric.